Hello, welcome to our CompTIA A plus class, lesson 16. Our topic we're looking at conferring SOHO and network security. If this is the first time you join our channel, I want to encourage you to subscribe to our channel so that you keep getting more videos from us and more trainings from us. So this channel is all about tech. So we are developing the next generation of cybersecurity professionals. We also empower people in terms of tech. If you want a career in tech, this is a channel that you have to follow. So this is CompTIA A plus. From here, we're going to go to networking, then we go to cybersecurity, then also we're going to give videos as well concerning the latest technology, the latest vulnerabilities and threats in town in terms of cybersecurity. Okay, so without wasting much of time, we're going to start lesson 16. So the topic for today is configuring SOHO network security. So that's the topic for today. Configuring SOHO network security. Okay, here we go. So what will be our objective? So this is going to be our objective for this class. We're going to explain attacks like threats, vulnerabilities, compare wireless security protocols, configure a SOHO router security. Then of course, we're just going to do a summary. Okay. Now, we will look at an attack, threats, and vulnerabilities. So, what is an attack? What are threats? And what are vulnerabilities? Right? Good. So, let's take a look. Now, we in information technology, we have three core cybersecurity components. We call them CIA triage. These are core functions in cybersecurity, the three core components in cybersecurity. So we call it confidentiality, integrity, and availability. These are three core functions, three core components in information security. Right? Okay, so confidentiality, integrity, and availability. So when we say confidentiality, now is the ability to ensure that the information that is being sent, is not being intercepted on the way, is not being hijacked, right? The information, it gets to the same person, who have that information. So in other words, we are talking about confidentiality. We are saying the ability of the message to remain the same way it was sent without anybody intercepting it. So it's going to be the same way, confidentiality. So if I sent a message to you, there's going to be, that message has to get to you the same way I sent it. We call that confidentiality. So the same way I send a message, the same way I expect the message to get to you, we say is confidentiality. So your password, your everything, that you have to access that information is left for you only. You only have the information, no other person has it. Then we talk about integrity. Integrity is the ability of that message not to be tampered with, right? Now, it means that if I sent a message to you, right? For instance, I sent the content of the message I sent to you is saying, this is a boy. This is a boy, right? Now, by the time the message gets to you, right, the content must be proving that what is not being intercepted. So this is boy, we're still going to be there. So either there's a question mark, a comma mark, a full stop, none of them should be added. So when the full stop is added or a comma is added, that means what the message be tampered with. You understand? So the ability for the message to remain intact, the same way it was sent, the ability of them to remain intact, that will call what integrity. So if an attacker intercept the message and had his own information inside, right? You should be able to verify and know that that message was not the way it was sent. It had been intercepted and it had been worked on. So the ability for the message to remain the same way it was sent without being intercepted is called integrity. Then availability. Availability means that at every point in time, the information is available to you to have access to at all time. That's availability, right? Okay, good. So now when it comes to security assessment, there are two key things we need to understand. There are three things anyway, so but we're going to look at two main ones, which are called vulnerabilities. Yeah, vulnerabilities is the weakness. The weakness. When we say the network is vulnerable, I mean it's open. There's weakness. It can be attacked. So someone that have noticed the weakness inside, then we call it vulnerability, right? So it could be an asset, right? So the ability for someone to exploit your network, to exploit your system, your server is vulnerability. It means your system is vulnerable to an attack because they've seen a weakness there, right? Now, threats. Now, when your network is vulnerable, which means yours becomes a threat. So that means that whatever is considered vulnerability is seen as a threat. So which means there's a threat in your network, somebody can come in. So when an attacker sees a threat, a weakness, that weakness you see becomes a threat, right? It becomes a threat. So a threat means that it could be anything. You could have a malicious code, you can write a malicious code, and used to exploit vulnerabilities. Also that kind of threat, right? So threats are also internal attacker that threats. So all these are attackers. Attackers are, we call them threat vectors. Those who have the skill set to be able to hijack, sniff your network, right? Those ones that can exploit vulnerabilities in your network, that can exploit the weakness in the network, we are called the threat vectors. So most of the times when we go to the internet and we notice that our system has been tampered with, those who did that are called threat actors. So they're usually the attackers who attack systems. They are called threat actors, right? Now, when we are about attack vectors, right? Attack vectors is the medium, the tools which they use to attack you. These are vectors. What they use to attack you is called vectors, right? So threats could be internal as well. A threat can be an internal threat. So an internal threat is somebody who is in your system, probably member of your staff, member of your team. Could be an internal threat, right? So it might not be intentional. It might be by mistake, by error. Probably one of your staff downloaded a software on the internet, and those software, what happened? They bring you malicious codes to the system. So when they bring the malicious code to the system, what happened? That's an internal threat, because that code can go down as much as temporary the systems that work in your organization. So we call those internal threats, right? So external threats, of course, those who are not part of the system internally, those are external people. So they can, you can be you going to the internet, be working on the internet, and the same way you get a malicious code on the internet, you are being exposed. Those are external form of threat, right? Now, when we say vulnerability and threats together, those two combined together, they give what we call risk. They form risk, right? So risk is actually the likelihood of an impact to occur. That is risk. The likelihood of an attack to occur. So the likelihood of an event to happen is called risk. And if you're looking at risk, you are going to measure the impact. So if this event occurs, how is it going to impact us? What is the likelihood of the impact? How is it going to look like? Right? So that is it. So risk is the likelihood of an event to occur. So if something like to happen, it becomes a risk. Right? So when you have vulnerability and threats, all these things together, they will call they form what we call a risk. They become a risk for us. And it's something we have to look at. Okay, so we talked about vulnerabilities earlier. We said vulnerabilities are weaknesses, they are vulnerabilities. So it means we are exposed, our system has been exposed, right? We call them vulnerabilities, weaknesses that are being seen in your system are called vulnerabilities. So it's a medium of exposure in your system, it's called vulnerabilities. Okay, so now what are forms of vulnerabilities we are normally common with? The first one we have non-compliant systems. So a system that is not compliant, is not in compliance. For instance, there are standards, there are basic standards in information technology. In terms of cybersecurity, there are standards as well, right? Now we have standard like the ISO 27001. These are standards in cybersecurity. So if you have a standard and your system is not following the standard, right? Then there's a vulnerability, there's going to be weakness there. And also, if you have a company policy about our system being used, security baseline, how has that been handled, how that been used, and some set of computers in the system, does not follow those guidelines, does not follow those configuration baselines, don't follow them. So those are also form of what risk as well. So you must be able to have your system should be configured in a way that they follow security protocols that been laid down by the IT department or the cybersecurity team. So the system whereby the information protocols are not being followed, whereby standards are not being met, which means that shows that what those are non-compliant systems and they are what they're vulnerable to attack. Vulnerability scanning, right? Now, we can scan a system for weakness and vulnerability, see where problem is coming. So we can scan, so we'll scan a system for vulnerabilities, weaknesses, and we see those vulnerabilities. What we have to do is to correct them. If you don't correct them, then of course, which means those systems are, but they're still what seen as not compliant systems, right? Then unprotected systems, of course, unprotected systems are systems without antivirus, without firewall rules, firewall securities. We call those ones unprotected system. So your system must have a firewall, installed, and of course you must have a firewall that is going to set that you set in. Create firewall rule, define who should come to your network, who should have access to your system, create all those rules, right? So we have software and zero-day vulnerabilities. So what are zero-day vulnerabilities? Now, when it comes to software, when a system being developed for the first time, I'm talking about application now, right? Now, when you build a developed application on the first time, you're developing it without going live, right? Before the system is exposed to the internet, to the world, right? There are normally errors, there are bugs in those systems. Now, when those bugs are not discovered earlier, and you go ahead to publish, go live with those applications. So when an attacker, sees vulnerability in those software, those systems, sees it, right? What they do is what they can now generate call zero-day exploit. So we have zero-day vulnerability, we also have zero-day exploit. So the zero-day exploit is the malicious code the attacker will now use to attack those zero-day vulnerabilities, those errors, those bugs in your code. So zero-day vulnerabilities usually are vulnerabilities, are weaknesses, that is in a application, a system, when it's being developed, that have not been discovered by the application developers. They didn't discover it on time and they went to launch it. So we call those on zero-day vulnerabilities, which means an attacker can seize them and can see those vulnerabilities, those weaknesses in them, and create what we call a zero-day software, a malicious code, and use it to attack the system. That we call zero-day exploit, to exploit the system. Right, good. Then of course, we also have what we call the unpatched and end of life operating system. So most of us we are aware about Windows update, right? Very important. So one of the common things we have to do with our system, so we'll install updates. So updates always go to systems and looking at which component, which part of the systems that are maybe the patches inside, they are becoming obsolete. So updates always correct them, correct those patches. So patches are not being updated, they have not been corrected. Updates will always correct them. This update can correct them. So always update your system, not just Windows, your phone, whatever device you're using. Always update them. All right. So you must also ensure that automatic updates are enabled on your devices that you're using. The end of life operating system. So every operating system, everything in existence actually have end of life. So your car, everything you have end of life. So that includes what your operating system. Every operating system they have end of life. So for instance, now we used to hear about Windows 10, right? Today Windows 10 is now has gone to its end of life. It's not in existence anymore. Even though people use it, but it doesn't get support. So if you're using Windows 10, it means that if you're on the internet, there's no support. Your system is exposed to a lot of threats. Exposed to malicious code, exposed to attacker, and exposed to virus and so many things. So those kind of systems, if they're part of a production network, enterprise network, they're going to be a major problem for the network, major problem for that network, going to be a major weakness. So an attacker can easily gain access to the network through those systems, those Windows 10 systems. So when this thing gets to the end of life, the first thing we need to do is take it out of the network. You can use it as a standalone, but it's not part of your production network. Then bring your device vulnerability. So now most of the times people go to organization when they get there with a system, they want to use that system, maybe gain access to their Wi-Fi, get access to some files, and they want to use. So bring your devices. Could be USB devices as well. It could be your laptop. It could be your phone. They call them bring your devices. So when you take it to organization, because when you work at home, right, you can do a lot of stuff. You could watch games, videos, go to different websites that are prohibited. I'm also do website, they contain bugs, they contain malicious codes. So if you go there and malicious code is down to your system, a malware is in your system, and bring those devices to an enterprise network. So what happens is that those devices, right, those devices will be affected by this code. Those code they're going to repeat themselves. They're going to be downloaded to this network. Depending on if they are warm, for instance, warm normally duplicate themselves in the network. And when they do that, which means what? It's going to affect the system. Right? Now a malicious code also it could be a backdoor code. So now a malicious code will be in a way that an interceptor, an attacker, use that code to gain entrance to the system. We call it backdoor. So a malicious code to be something that was installed on your system that will give an attacker the access to remotely connect to your computer. Those are called backdoor. So when the code is in the system, it can connect to this. The attacker will connect through this code to the system. Then that's backdoor. When they get in there, then they begin to work it. From there, they can look at where they can have create access to themselves and penetrate the network. So it's very important for us to understand about bring your devices that we must have security rules, security policies that prevent that. Even if a system has to be part of a network, you must have your standard opening procedure when it comes to security wise. How systems are being scanned before they are being used. So you must have your security baseline in place. Every device that comes in, what application allow, what can they have access to? So you must be able to do that, right? So that is bring your own devices. So social engineering, impersonation, this is very common, right? So impersonation, somebody gain access to your devices and start using them, maybe a flash drive or whatever, start using them. You gain access to your network and stuff like that, and start acting like you. You could be a user, right? Somebody gain access to your password to your system and connect to your system and start using your system, like sending emails to every other person. That's impersonation, right? With texting, it could be, the same way someone can just use your name, your gain access to your phone and be sending a phone-led message to people. You understand? These are forms of what impersonation. Dumpster driving. So dumpster driving is very important that we notice that. So a situation where you have trash bins, you have some document that you want to trash out, and those documents contain important information, but just because at that point in time you just feel that you don't need them, you just put them on the bin. So somebody can go into this bin and begin to look at those things and see important information and use them in your organization. So it's very important that we know what called dumpster driving. So what you have to do in terms of dumpster driving, before you dump office documents, ensure that they are well destroyed before you dump them. So there's this machine we used to do that. You can use to be able to destroy it's only an organization, right? Use it, then you trade them and you trade it, destroy it, and you cannot put it on trash, right? Shoulder surfing. Shoulder surfing is whereby you are walking somewhere, maybe you're trying to kill your password and somebody's behind you without you notice, just looking at you, whatever you're doing, and he's stealing your password, looking at your password, looking at everything. So what they did is steal your confidential information. They can use it. It can use it, and when you're not there to use it to log the system, including when you go to ATM machine, always let people give you distances like 10 meters away from you. Don't let people come close to you. It's very important. So those are called shoulder surfing, right? Tailgating and piggybacking. So what tailgating and piggybacking, they are similar in the sense that is when somebody gain physical access through you. Let me explain now. Now, what I mean physical access true, assuming you're trying to enter a security door post and you only have the code to enter, somebody behind you want to enter through, get access, but the person doesn't have the the access code to come in. So you have the access code as you are entering, gaining access to enter. That person, just followed and enter with you without you knowing. So those are called tailgating and piggybacking. So somebody gain access to the barrier without you knowing. So you open it and before the person has passed and you didn't know. So that is tailgating and piggybacking. Now the difference between two of them is that for tailgating, right, you do not know that the person followed you, get access through you. That when you open it, someone just sneaking, you didn't know. So that is tailgating. Person, you are unaware of that, right? That is tailgating. For piggybacking, right, the same way, but this time around you are aware. The person might just trick you. I said, please, I just need to get something there. You will not know. I need to have access to, I need to see somebody in that place. Pretend like it's a legitimate person. Could be a visitor. Pretend to be a legitimate visitor as if you want to see somebody. Then meanwhile, his intention is to steal information. That is intention. To get access and steal information. So all that that is tailgating and piggybacking. That all form of social engineering. Okay, so phishing. So phishing is very common. Phishing is very common. So in phishing, we have social engineering, spoof messages. So once it's social engineering, we get messages through our emails all the time. People trying to deceive us. Tell us that they're from the bank. Or trying to tell us that they have one kind of special offer for us. All these are forms of social engineering. Now, spoof messages that when someone's changed their identity. So you will not know that true identity, right? You send a message, you've changed identity, pretend to be somebody else. They are called spoof messages. So they use another form of identity to spoof the website, to spoof it. They are called those are spoof messages. So you can't get them because you change identity. You use somebody else. They use somebody else's device to send you messages. You think it's that person. Meanwhile, they are spoof messages, right? Then spear phishing. So specifically the same thing. Some trying to send you messages, trying to claim, trying to deceive you, and those are a form of phishing, spear phishing. So it could be an email that was sent to you and trying to target you and trying to get some information from you, some vital information, steal it from you. All these are spear phishing. The word about walling. So walling is a kind of social engineering trick that is targeted at. So walling is targeted at high executive, those senior executive that they are targeted at them. Now, like the CC suits, the CEO, the COO, CFOs, all those messages are targeted at them. So trying to impersonate them to get information. So we call it walling. So if you see an email, someone trying to tell you that it's the CEO of a company, CEO, CFO, stuff like that. Now, before you get to send email and confidential information to them and whatever, or someone is sent you telling you that this person you want this, that CEO, you must have to verify and do your investigation very well, right? Then vision a voice message that have been sent. At times get a call from the bank. Right? They're not really the bank person, they just call you, let you know, telling you that they are doing an update with their systems. So because that they want to know your password, your smart card, so they can use it to update it. So all these are phishing from a voice call. Don't listen to them, right? If your bank needs to update you, get password from you, they don't want to call you, to be honest. And besides, your bank doesn't need to get a password from you, right? They don't need that. So your bank to change your password, all you need to do, right? So send a message to you directly. They will not call you, to your email, and you will know because you have the official email address. You know through the official email. You will know from the message that has been sent to you that this is actually from the bank. If you're not sure, you can go to the bank office directly and verify the email. All right, very important. Evil twin. What are evil twin? Evil twin. They are rogue access points. I mean, rogue access like fake access points. They're not real. They're not the real one. So let me explain. Now, so somebody we call it spoof access point. We call it that is evil twin. Now, which one play rogue access point. So you have an access point, So an access point is that device that give you access to the Wi-Fi. So somebody come in with another access point and put the access point, in your organization, and before they put it there and they did some setup inside. So that setup will now connect the access point to your company's network. So what means that the person now and I will now have access to the network through the work of that access point. So we call that evil twin. We call it evil twin. It's spoof access point. It's called an evil twin. Spoof. So they fake it and put it there. It's called evil twin. Right? Okay. So now, so threats. So let's look at some common kind of threats. So we have external and versus internal threats. So the external threats are attackers outside the organization. They're not part of your company. They're outside of your company's enterprise network. They're not in. They're outside. We call them external threats. Internal ones are most likely your employee, your staff members, your colleagues, those working with you. Now, they might not be intentionally trying to cause a havoc on your network, right? They might not be intentionally trying to bring the network down. No, it might just be some things they do, right? So that makes them internet threats. It might do some certain things like download the applications or that go to the internet. They're not allowed to go to visiting sites. They're not allowed to visit. So many things that using a flash drive. Installing applications that are not allowed to install. All those ones are form of internal threats. It could be an intentional internal threat anyway. So an employee can just be internally just want to bring your network down, just to bring your system down, just want to steal information, right? An employee can just be that. So that's why we have to be very careful with the kind of employees that we have, right? Then footprinting threats. What is footprinting? Footprinting is a method through which we can get information about not just organization, a person, right? To just about anything. That is footprinting. So most times we find that we give out so many information about ourselves on the internet. When we go to the internet, at times we fill some question. Now we give out a lot of information. Even at times, on our social media page, we say so much on our social media page. All right. So by doing that, we give a lot of information. Right. So spoofing threats. Spoofing, I've already told you. Spoofing threats is when somebody changes identity to be able to get to. We call it a spoofing threat. On part attack. On part attack is when somebody intercepts your communication. Maybe you are communicating with somebody, right? You are doing a communication with somebody, maybe a colleague, remotely or locally. You are doing communication. So to you, if you feel you are having a conversation with somebody, right, through the internet, through the network, that way you think. But meanwhile, someone else was intercept that communication. They will intercept it and hijack it. So when they've done that, what they do, right? So they will not be replying you. You are working, you are sending a message to that person, someone have hijacked your message and accept it and change it and be replying you. Right? We call that man in the middle attack. It's called on-part attack, it's called man in the middle attack. So we call it the man in the middle attack. Somebody have hijacked your information and start acting like they are you. Denial of service attack. So denial of service means that you are on the internet, right? So you're trying to open a specific website. All of a sudden you can't open that website anymore again. So you know what it means? An attacker is denying you that service to access that website trying to go to. So we call it denial of service. So you are being denied of service. It could just be something else you're trying to do, right? So you're trying to do some things, trying to have access to some services. Maybe you're trying to connect remotely or trying to do a file transfer, which is FTP, file transfer. You're trying to do that and you couldn't do that. It could be that you are being denied to use that service, right? So those are a form of denial of service attack, whereby the attacker will deny you of a particular service. They also have distributed denial of service. Now, distributed denial of service is similar to denial of service, but in this time, it's going to be very cumbersome, right? Because now you don't. It's not just one device that is trying to interrupt for the service. There are multiple of devices, who are sending you, they're sending so much traffic to your system. So just to deny you access to that system. So there's what we call command and control, right? Let's take a look now. Take a look now, right? So this is the user now working in this place now, right? So the user is working here, working on his own, trying to have access to the web service, right? So these are web service. For instance, let's assume these are the internet. These are trying to have access to this the internet now, right? So what happened is that there's a threat actor here. So we told you earlier who a threat actor is, right? Good. The attacker is usually a threat actor. When I try to gain access, unauthorized access to your system, we call them threat actor. Now, the threat actor, what they do, they send bootnet. When I mean bootnet, you can see bootnet, right? They send, a lot of bots out, who will now go to the system, right, and be distributing, loads, traffic to your devices. So a lot of them, see, each of them are giving traffic to your devices. See? So this is the giving traffic to devices, right? So now there's C and C there. That means the threat actor has a system that is controlling all this thing that's happening. So he's sending that, he's distributing traffic to all distributing messages to all the bots, and bots are flooding your system from different angle, right? So that is the threat actor there. That's what he's doing. So he's doing that from a command and control. Now is that the system where we sit down and control all the activity that is going on. So we call that distributed denial of service attack. Okay. So let's look at password. Right? I think we need to be fast a little bit. So let's look at password. So we have plain text password. So plain text password, they're always risky, right? Because why? They can be intercepted on the way. So they are sniffing application like Wireshark. So Wireshark is one of those sniffing application that when you set it up, and monitor it, you will see all the passwords that are being transversed over the network. Right, you see them password, because Wireshark captured the network traffic. So all the traffic that are going on, when it comes to password, you see the password and plain text. So it's always best to ensure that you use password hashes, right? Instead of just plain text password. So password hashes are. So password hashes, full of what hashes? Hashes are just a fixed length of text, that are in form of a string format. So like we have different kind of alphabets coming together to form a string. So in a fixed length, we call it hash. They are hashes, right? So good. So now we have hash password file database. So hash password file database is a file database that hosts all the hash of the password, right? Then we have hash captured in network traffic, like I explained now. So a network administrator, right, can set up a system to capture all the traffic that is going in network. Typical example is Wireshark, right? With Wireshark, if you install your network, you will see all the traffic that are going in and out of the network. You see them. You can capture the traffic and you can analyze them. Now you could tailor your search, right? You could tailor your search to just network traffic, just hashes. So you will see password, you will see hashes or password, right? So with that, you could get those password or those hashes online, capture them online, and use what we call a dictionary attack, right? To be able to break this password, to hash this password. That will lead us to the password hash cracking. So you could crack the password through the dictionary attack. Brute force attack is repeating. You are guessing password. You are doing it all over, guessing password. Even that is brute force attack. For additional attack means that you already have a file, where you have different kind of password compiled already. It's like an automated system, right? So what happens is that additional attack, right? You can use to crack password in the sense that in dictionary they'll have a list of suspected password that they can use. So what happens is that the automated software we work together with that system and try to be looking at the system one after the other, trying different passwords until they eventually get it. So that's called dictionary attack, right? Okay, so let's look at some interesting topic now. So cross-site scripting. So when we talk about cross-site scripting, these are just These are just scripts, that are sent to web pages. It could be on the server, on the web server, or on the what, on the client, right? When I say web server, we're talking about web application that is hosting a website online, right? Then when I talk about a web client is just the browser. Like we go to the internet all the time, we open different sites. These are web clients, right? So cross-site script are scripts that are sent, to those websites. That script will send. So we have the server side and we have the server side versus the client code. So the server side is just the code, the script that's written for the server, which will be for the web application, while the client side are scripts, are code that are written for what the client side. Then input validation. Input validation, what is talking about is just having a way to validate and inspect, if the word is to inspect and validate every code that's been written, to ensure that the code follow a standard format, right? Like in terms of the length, the font, and just ensure that the code, if the code follow the standard format. That's input validation, right? Okay, so what about cross-site scripting? So cross-site scripting, they are malicious code that intend to exploit input validation vulnerability. So when I mean malicious code, they are injected to your web browsers, right? So web browsers like just name them. Web browsers are, your Google Chrome, Firefox, Edge. All these are web browsers. So you could insert a malicious code to this website, inside it there, right? So when you start it there, so they could exploit the wrong input validation. Like we talk about input validation now, we said these are code that are written, to inspect the template, and they inspect it and they ensure that they inspect it, and to ensure that the code follow standard format, right? So when there's input vulnerability, when the code is not following standard format, which means it's possible that what a malicious attacker can write what a cross-site scripting, right, to exploit that input validation. So what about a non-persistent and persistent when it comes to cross-site scripting? Persistency means, now let's look at something now. A lot of times you can be working on a system and all of a sudden your system is not working anymore. Maybe it's slow, it's hanging. Now that could be as a result of a malicious code that you downloaded, right? So it could be a malware or so, right? So sometimes if you are smart enough, you can restart the system, shut it down, restart it. So when you shut down the system, restart down, the system boot back to desktop environment. You notice that the system is now working normally, which means whatever errors it was producing earlier wouldn't be there anymore, right? Good. That is persistence. I'm sure I understand. So that is not persistence, rather not persist. That is not persistent, because by the time I reset the system, right, the error was no longer there. It's called not persistent. Persistence is when we say persistent. Persistence means that you reset the system, you restart it, shut it down, and put it on again. And the system came back to the desktop environment and still behaving the same way it was behaving. Because the whatever is causing it, the malicious code is still there, the malware, everything is still there. We call it what? These are called persistence. So we need to understand not persistent and persistent. So the first thing we always do when you get if you're working at times, you experience them misbehaving, give some unwanted errors, and what you have to do at times, you just shut down and restart all over again. It might just be non-persistent. We just correct it for you, right? Good. So then also we have arbitrary code. Of course, the same thing with cross-site scripting. What they do, cross-site scripting, the arbitrary code. So they work to steal, intercept from data, or install malware. That's what they do. So that's at times, some browser at times you see you go to a browser, you open a browser, and you're seeing the browser is acting funny, because why? An attacker has inserted a malicious code in our browser. We call it cross-site scripting. So you see the website just misbehaving, bringing a different pop-up, and on and on. Those are a form of what cross-site scripting. Okay, so what about SQL injection? So SQL injection are just those are just that when a malicious attacker inserts a malicious command into your SQL command, insert a malicious code into your SQL command. So we call them SQL injection. So they insert a malicious command, malicious codes into your command that you do. Probably you're trying to update your table, right? You're doing update and somehow, so you're trying to update a particular data from your table, and somehow an attacker managed to hijack that command and inserted something else in your command. We call that what? SQL injection. Threat actor. So so that's about SQL injection. Okay, so let's continue. So hashing and encryption, we explained hashing earlier, right? So I told you what hashing is. So I said hashing are just your password are being compressed to fixed length of strange characters. We call it hashing. Strange of fixed character, right? And hashing usually is what we use to preserve integrity, like I try to tell you. So integrity in the sense that, like I explained when I earlier on this topic, when I was talking about the three components of cybersecurity, the CIA triage, confidentiality, integrity, and availability. So I said hashing is to ensure that what the message is not tampered with on the way. That's what hashing does. The message can never be tampered with on the way. That's hashing. So hashing can, when you hash a message, ensure that even if somebody, an attacker, manage to have access to that message, right? Because the message is hashed, they're not going to see it because it's an hash message. They will wonder what is this. They will not do anything, right? Yeah, because even they try to hash it, you will know. Because why? When you get the message, there's a way you can find out that this message has been tampered with. So symmetric encryption and asymmetric. Now, we need to understand something about encryption. Encryption is to change to make your work look different, to change the format of it. If it's plain, you change the look, the appearance, everything, like giving it a secret, make it discreet. That's encryption. So if you have a plain text, you can encrypt it by the command called ciphertext. Cipher is what to encrypt encryption, right? Then there are two types of encryption. We have the symmetric and what that's symmetric encryption. Symmetric encryption, first of all, we need to understand that when you encrypt a message, right, the only way you can get the message back, means you have to decrypt that message. So when I encrypt a message, I need to get it back, right? So what I have to do, I have to decrypt it, right? So encryption is, there's in encryption there is cipher and decipher. Cipher is the process of encrypting the message, while decipher is the process of what decrypting the message. So we have to understand about encryption. Now encryption, like we said, you have to encrypt the message, then you have to decrypt it. So when it comes to encryption, right, there are two methods of encryption. We have symmetric and not asymmetric. In symmetric encryption, when you encrypt a message and try to decrypt it, you just need one key. We call it private key. That we just need. Symmetric encryption is just one key to decrypt. We call symmetric encryption. Now, to decrypt. Now, we won't get to asymmetric encryption. Then you need two pairs of keys. So you have to call the private key and the public key. So the private key here, it depends on how it's been applied. So you can use the private key to encrypt and use the public key. You can use the public key to decrypt it, and you can use the word private key to decrypt it. Now later on, you're going to see, again, I said you can use the private key for what? To decrypt, and you can use the public key to encrypt. There are times you have to use the public key to encrypt and the private key to decrypt. So we're going to see that, in our next slide or so, right? So, okay, good. So let's look at what we call digital signatures. What are digital signatures? So in digital signatures, we're talking about where encryption and hashing comes together to protect, our online presence, right? To validate a message certificate. So that we call encryption. So again, I said where hashing and what encryption, encryption is a key. We'll talk about key pair, public and private keys. That's encryption. Why? Because a digital signature. Digital signature that the hashing are being used and what encryption are being used. So encryption are the public keys. Like when I talk about public keys talk about simply about what encryption and decryption. that we're probably is talking about, which is, well, I'll talk about encryption. We're talking about two types of encryption, symmetric and what asymmetric. So those two come together, which I call key pair. So we can use them to validate a message or a certificate, right? So I wonder what certificates are, right? Good. So certificates is is a way to authenticate your system. Just like you want to test something, you use a certificate, yes. So certificate in cybersecurity is where we authenticate user, give them verification on the internet. Those are called certificates. Where when you move on to cybersecurity, you understand better, right? Okay, so we talk about digital encryption. We're talking about what private key and hash coming together, like we explained, right? So the private key to encrypt. Yes, take a look now. Here now, they say the private key encrypts a hash messages. See, private key encrypt a hash. That is when it comes to digital signature. The private key is to encrypt your hash. So the hash messages you have now. Private key have to encrypt their hash messages. The public key will not decrypt it. So remember, we talk about encryption and decryption, right? In digital signature, encryption and decryption. So now we use the private key to what encrypt, and we use the public key here what to decrypt. That will happen here. So in digital signature, the private key are used to encrypt your message or certificate, while the public key is to what to decrypt the messages. Don't worry, the more you get more further into this, you're gonna understand better, right? Okay, so let's go. So let's look at key exchange. Now, key exchange is talking about the keys that are being used, in communication. Now, use key pair to protect exchange of bulk encryption secret key. Now, a public key encrypts secret sessions on key. So first of all, what is the session? Now, every time in computer, in network communication, right? Each time you try to make a communication, you try to send a traffic. Each traffic you send is a session. If you send a request, trying to make a communication with another computer on the network, that is a session. So in other words, that session will not end. That session will only end when you are done. That session will end. And every session has a key, session key. Every session that is open has a session key, right? That what we're seeing here. See, public key encrypts secret session key. A session key is a terminology. A session key is a temporary single-use symmetric encryption key generated to secure specific communication session between two devices. So that was a session key. So session key is a temporary single-use symmetric encryption key. So that temporary keys that we call them session, because the moment the session ends, the moment that communication ends, that session ends, right? So private key are used to decrypt session key. In this place now is vice versa, right? Earlier we said the private key are used to encrypt hashes, while the public key to decrypt hashes. Here now we say the public key is to encrypt session keys, while the private keys will decrypt session keys. So it's very important we understand that. There are times where we have to use the private key to encrypt. There are times where we have the public key to encrypt. So it works vice versa, right? Depending on this. So just notice that when it comes to hashes, right? So we use private key to encrypt hashes. Just know that. Then we now use public key to decrypt hashes. When it comes to sessions, right? Those sessions, they have session key. So those sessions key, we use the public key to encrypt them. How is the private key, right, to decrypt? So that we need to understand. For hashes, it's just straightforward. For hashes, we only use private key to encrypt hashes, public key to decrypt hashes. Just so know that now. Okay, so that's about digital signature anyway. And that takes us to the end of lesson 16B, 16A. So let's look at 16B, wireless communication, right? Wireless communication. Okay, so now in wireless communication, there are protocols we have to follow. So in wireless communication, there are protocols when it comes to security. For instance, now we have the WPA, wireless protected access, right? Good. So that's the first form of wireless security protocol that we have, right? Okay. So the Wi-Fi protected access, like I said, it's called Wi-Fi protected access, right? So those are the first sort of security policy we have in terms of wireless networking, secure wireless network, and they use the temporary key integrity with RC4 cipher. So RC4 cipher, this is an asymmetric encryption key. It's an encryption, right? The more you move in security, you understand. So that's what they use. Then of course we have the stop gap and tend to fix flaws. And so now let's just go on and on. Let's move on to this place, right? So we have one, two. This is the latest one now. So let's focus on this. So WPA2 is stronger than this first one. They use what we call advanced encryption standard. That's what they use here. So it's stronger than the first one. Then let's move further to the Wi-Fi protected access version 3. So a Wi-Fi protected access 3 is far stronger than WPA and WP2. So it's an upgrade of WPA2 in the sense that it is what called simultaneous authentication of equals, right? So it's what called simultaneous authentication of equals. So what is simultaneous authentication of equals? So it's a secure password-based key exchange protocol that use WPA personnel to prevent offline attack and secure, provide mutual authentication and establish individual data encryption. So now we're trying to say that one way to prevent additional attack, that we are seeing here now, to ensure that we use what this WPA3. That one has to prevent additional attack, to prevent offline additional attack from your network. So that's just what is just explaining us now. Okay, let's move further. So still on wireless network, we have open network, enterprise authentication. So all these things we need to understand are just way of setting password on your system. So if you are using this one, WPA, it has a called shared authentication key that we can use to securely our network, right? Now we can go on and on. Then of course we look at WPA3 personal authentication. We just talk about it now. That is far secure than WPA2, right? Okay. So let's move on. Let's move to the next slide. Okay, so let's look at this is a form of wireless authentication, right? Let's look at 802.1x, right? So the 802.1x is a wireless security protocol that we can use to authenticate users, right? Most especially users who connect to the network, through a user's account, right? So network directory holds account details and permissions. So 802.1a can allow that. Then of course we also have what we call the access point short, like extensible authentication protocol. Now the ETA, what the ETA does is to ensure that we have different form of authentication method, like to ensure smart card are being used. You want to use smart card, you want to use different form of authentication method, right? That what the EPA supports. See, EPA supports multi-factor authentication method. That what the EPA supports, right? So understand these two. This one, 802.1x, provides information about these two detail. So it tells you about how account is being used on your network and permission. We're going to see example like what called the remote user dial in. So they come under this 802.1x, right? They are form of enterprise authentication protocol. Then we have EP that's allow for the use of smart card. So when you see smart card, then it will being used to log to network is at the help of the extensible authentication protocol. Extensible. So not just smart card, it allows for that form of authentication method as well. Okay, so we talk about the radius now, right? So I just have to explain this very fast, right? So we'll talk about radius. It's called remote authentication dial user services. So this protocol, right, now is what enable a remote user, right, who has credential to access their enterprise network in order to access his corporate network. So the user travel out of town, probably went on business trip and is in UK, for instance, right? They trying to have access to their to the company's server in US. Now, the user need to have access through what username and password, right? So the user login gets to the process whereby the user must be authenticated and authorized, right? So when users log in to be authenticated and authorized, that process is what called radius server. So it's radius server that allows remote dialing user service. That we call it remote authentication. So the user must connect with user and password wherever he is to have access to that network. So the process of doing radius system is quite longer, because at the point in time that you must have access points for clients. So you have devices who are there who can join the network as client, who can join the radius server like your access point. You can join the server as a client, because you can use wireless anyway to connect remotely, right? Of course, those devices, because since I talk about networking, they must have IP addresses, of course, they must have password, that will shared secrets connected to them. So what you need to understand about the radius is that the radius authentication, we call remote authentication dialing user service, is a process whereby users can connect, through remotely through their to their corporate network, through their user's name and their password, to their credentials. That's remote dialing. And of course, the process that's involved, it involves some devices being acting as clients, that can be to give access to all these things. So that is that. Then the next one now is terminal access control system. Terminal access control system. So this one is why the first one is talking about user. This one focus on more about device authentication. Right? It focus on device authentication. How attackers. So take a look now. Often used to authenticate and authorize appliance administration rather than end user. So it's more about the appliances, authorized appliances than user. So this radius is for user, while this one is for what? Devices. Take a look now. Let's see some more explanation about tags, right? He said terminal access control plus is a network security that provides centralized AAA. So it says centralized AAA. What is AAA? AAA means what? Authentication, authorization, and accounting management. So that's what it means in computing. Authentication is a process whereby you have to enter what the user's name and password. That's authentication. Provide your credentials to log into the network. Authorization is ensuring that you have access, to use a resource on the network. So if you don't have access, if you don't be getting permission, if you're not authorized to use it. Accounting is to ensure that whatever you've done on the system, can be accounted for. If, for instance, now I've accessed a resource on the system, whichever way, whatever I've done in the system can be traced, has to be traceable. So that will call accounting. So that is that. Okay, so KBS authentication and KBS authentication and authorization for single signing. So KBS authentication is just easy, right? Log in securely with your users and password. We call it KBS authentication. Easy. Log in with the domain, user and password, right? Single signing means the same password and username you are using to log in here, you can actually log into another application elsewhere on the same network. So you don't need to be providing different you don't need to log in all over again. So you log in once, that once log in, you just take you through. So okay, so let's continue. Okay, so that takes us all the way to 16C. So this is about router now. So configure router straight up, security in router. So we're going to do that practically. So please, I want to encourage you, just stay tuned to my YouTube channel, right? Stay tuned to my YouTube channel. We're going to have a practical demonstration of how to configure a router. Very important. How to set up a router. We're going to do that, right? So but for here now, we cannot say so much because it's just like theories. So stay tuned to our channel. We told you how to set up a router, security in a router. But just in that, most of all these routers you see, most of them, it's SOHO routers, they have a web page, right? So you can have access to the router. Then you can see, just like this is a link, this is a TP link. It's a router now you can access. They have a firmware. Firmware, of course, we know of it as software that manages the entire hardware. So you can see this advanced, so you can get more configuration. Security, here you can cover security, about that. And Okay. So home router and LAN. So take a look at these are typical examples. So on advanced now, this is how to set it up, right? So this is wireless radio enabled, wireless network name. This SID, you can hide it. If you hide the SID, which means nobody sees it. So the network ID actually SID is we call it um, uh, it's the name of the network. It's the name of the network. So in our previous video, we explained it. This is just like showing the practical now, right? So that's why you have to go to check all our videos, all the way from lesson 1 to lesson 15 until we get to lesson 20. Check all our videos. We're seeing so many things there, right? So service set identifier, like the name says, service set identifier is the name of the wireless network. So most times when you see a wireless network, if you go to your wireless, you see them because those wireless, they are not hidden. If you hide it, nobody can see it. So hiding the way of providing security, so nobody knows about it, right? So yeah, now see this is security you're talking about now. They're using what WPA, W2 personnel. I would say the most highly secure one is using what WPA3. That is the most secure one, right? That ensure that what it gives a form of protection, mutual connection between the computers. So here now this password that has been set, the mixed mode of your on this is a form of way you set up the security there. So you see the password of the setup. So now home firewall router configuration. So the inbound filtering. So when we talk about filtering firewalls is all about network filtration. It's all about network management, how you manage networks. Both inbound traffic and outbound traffic. When we say inbound traffic, we're talking about traffic outside that's coming into our network, call it inbound traffic. Because they are outside that are coming in, call it inbound traffic. Then we talk about, mind you, also stating to our channel too, right? As time goes on, I'm going to show you how to configure firewall on your device, on your system, because all systems have firewall. I'm going to show you how to set up firewall on your devices. You can see how to set up a firewall. I'm going to show you that. How to create a firewall rules to block a specific IP address. So you want to block one IP or a range of IP address, I'll show you how to do that. They also have hardbound filtering. Hardbound traffic, in your entire network that is going out. We call it hardbound. IP address filtering, you can filter IP address like I explained. Content filtering, what to block and what not to block. Okay, so let's look at port forwarding. So what are port forwarding? Now, a lot of times we have network professionals who don't really understand port forwarding. Right? So I'll just explain it and that will be enough for this. Now, supposing, right, a traffic is coming out, and you want that traffic that's coming out to just get to just one device on network. Now, a traffic is coming, external traffic coming over the internet. So you want that traffic to go to just one device on network. Simply put now, we can explain it like this. You have an external person who travels overseas, and the person you want to connect to your network through VPN, virtual private connection. Again, stay tuned to stay with our channel. We're going to show you how to set up VPN connection too. Right? So the person is coming over, through the internet to have access to a device, which is set up by VPN. So when it's somebody outside, right, want to have access to your device in your entire network through the internet, you have to set up a VPN connection. Why? Because what? Your private network is a secured network, and person come over the internet, it's coming through an unsecure channel because the internet is an unsecured network. So someone is coming over the internet, they come to your network, your private network that is secured. There must be a VPN connection is set up. So that VPN connection is set up, right, must forward the packet from that user to that specific computer, your LAN. So the person outside trying to access that device now, right? The router inside must be configured in a way that it sees that packet coming in and it's that packet is for what? That device your LAN. So the router has to be configured to forward that packet to your LAN. That's what we call port forwarding. So in other words, the packet that comes out on the internet, as soon as the router sees it, because your router is already configured, to forward traffic, right? Outside traffic to that device on LAN. So it means that device on LAN IP address will be configured your router for port forwarding. So as soon as the IP address is there, the system sees that this packet, there's a port to this, so there's a report that whatever comes in from the internet will forward to this one. Okay, take the forward is now toward that system. So that is VPN connection, which means that user can be able to connect to what that's not the user connected by the internet. It hits your network. Your router sees that okay, this system, this packet is destined to these devices. It sends straight up to that device. So no other system gets it except that. That's what we call port forwarding. Okay, so wow. So universal plug and play. So there's so many ways to explain this, right? So let's take a look like plug and play, just the normal way in computing. We say plug and play, just plug a device and instantly start working. That is plug and play, right? Now, when we talk about universal plug and play, is different from our normal plug and play we are referring to, right? Now, this one is talk about a universal plug and play is just referred to devices in your LAN, right? Devices, it could be smart TV, whatever they are, all wireless devices. So long they are, they are linked to the internet, right? Good. So long they have internet, they are Wi-Fi, they are smart devices, all of them, they form what universal plug and play. In other words, as soon as the Wi-Fi is on, automatically they should be able to connect within themselves. So we call that universal plug and play. So let's take a look. Say allow LAN device and apps to automatically port forward rules associated with many vulnerabilities. Of course, it has many vulnerabilities because by default, every device they will just join the network by default. All of them. That's why it's we should call vulnerability. So it's possible that each particular device might have some some limitations or some weakness, whatever, and that device on the network, right? So which means an attacker can gain access to the network through that device. That's what we call vulnerabilities, right? So if a device has vulnerability and that vulnerability device join the network with vulnerability, which means that network has vulnerability because the moment an attacker penetrates and enter that system, from there they cannot see and they can gain entrance to other services you have on your network or other users as well. So universal plug and play is a set of networking protocols that let the device on the local network automatically find each other and connect with that manner setup. So you do just find them that start connecting. Like your smart TV that we're explaining, printers, all those ones, they are a form of universal plug and play. So what are screen subnets? Now take a look at this. There is a way we can set up our network, right? There's a way you can set up your network that your network will not be part of your entire network. It does not be part of your external network. If you do that, right, we are called that a demilitarized zone. We call it DMZ zone. That is screen network. So a screen network or demilitarized network, also a perimeter network too. The network that they are not part of your private network and also not part of your internet. They're on a separate place on their own. But they can access your private network, they can access your internet. But your device on your network cannot access them like that. No way. Access set up special access given to them. Same way, they can have access to the internet too. But somebody cannot ask from the internet access to devices. They are called demilitarized zone. They are not part of your network. They're just on their own. They're just in between. Right? Like someone is sitting on the fence. So they're not part of your LAN, they're also not part of your words. Like see what you have here, look at it, see these printers. See, this is a screen network, this is the demilitarized network, this is the internet. See, they are always on their own, they're not part of here, they are on their own. I'll call demilitarized network. Right? Okay. So security, it's all about security, physical security, all these doors and on and on. So these are not actually necessary so much for us like that. Most of us have physical securities and areas. CCTV, lighting, alarm systems. Okay, so that brings us to the end of lesson 16. So thanks for following. I'll see you in our next